I made this simple neural network with help of Claude that just tries to predict this image. So you have this image and you see how it learns. As time goes, it learns. And in the end, it's gonna reconstruct the image perfectly. And look at the loss. Now loss has some weird shape. We will explore why that happens, but loss is basically the distance in pixel values between the reconstructed version and this. So you can see that over time, the difference between them is smaller and smaller between the reconstructed and original. I will run it again for you. You see how quickly it learns. Yeah, it learned already. So that was it. The image is 64 by 64, and this is my network. So we have one linear layer, 1 as input and 512 as output. It's 1 because we are just giving it some random scalar, some dummy. This is not important because we are not converting any data into this image. We are just making the the network memorize the image. So it doesn't matter what we give it as input. It will always output this image. So we just need some random number as input, whatever. So we have these dimensions: reload, then expand, and reload and expand, reload and then expand again, and then sigmoid in the end. This is to output values between 0 and 1 for each of the 3 channels, red, green, blue. So we have pixels times 3 channels, so this is the number of pixels or values we need. Everything else is simple. I just load the image, convert image to tensor, and then train the model using Adam and this optimizer. So why does this loss function look so weird? So it's first because of the Adam optimizer. Adam optimizer is adapting learning rate per parameter, so it can lead to this loss going up and down slightly. It can cause small over or under corrections during training. Plateaus and sudden improvements. The model starts by learning large scale features, colors, rough shapes, which yield big loss drops. Later it works on fine details, which yield smaller and less consistent improvements, often resulting in periodic stalls or tiny regressions in training loss. So this is just model searching for optimal pixels. So it's gonna search and sometimes make some mistakes, but then it will find the best ones. So now we have some other experiment that I did here. We have some reports. So we have these 4 models that we are testing right now, comparing. So the first one is our original. So 500, this one, these layers, all of these layers here. This is what we already have. This is the medium. This is the third one. So tiny one is just 1 to 128, and then 128 to this image. So very tiny. So just one layer here, and then the output layer. Small is 1 to 256, 256 to 512, and then output. You see, it's different from the medium one. So medium one has more parameters. And then this is the wide. So this also has just one layer, but it's very wide. And then the output has a lot of parameters, a lot of connections. So this one is biggest, because this matrix is huge. Okay, so let's see the results. So I trained it. And first, parameters tiny 1,500,000. A small 6.4 million. Medium 27 million, and wide 37 million parameters. Average loss, you see that tiny and small have like a higher loss. Medium has the lowest loss. And then wide has a higher loss, because I'm guessing wide is very difficult to map everything onto a single layer. Having multiple layers is a lot better, multiple in the neural network. Here you can see the original image. So this is, I just generate 3 times. So this is after the training has finished. I just run it very quickly, very shortly. The first one is too small. It doesn't learn too much. We can see that loss is actually gradually decreasing here. So I guess if we continue training, it would decrease, but it's very slow. For this is the smallest, the tiny model. So I'll try later to just let it run. for longer and see where the loss goes. And then the second one, this is the small, you see loss is decreasing. It's a bit spiking maybe here a little bit and stuff. This is due to Adam. And the fourth one, the wide one that has only one, you see this is the problem, because there is a problem here because we have just one linear layer, so it performs as well as the second one, which is a lot smaller. So second one, even though it has maybe 6 or 7 times 6 times less parameters, it performs same because we have multiple layers as opposed to just one layer. You see that this wide one, the blue line, it's basically trying to have like a single function to draw this, while the red line, we have multiple layers, so it's like multiple functions to draw this line to fit the data. So it's a lot simpler, easier to fit data. And then we can see that our original architecture is the best one. It oscillates a bit more, but has the lowest loss here. So if I go scroll down a little bit, you can see this is the second one. It's just multiple trials to generate, and it's similar loss to the fourth one. And then the third one is the best. It has a lot of parameters, but also good architecture. It has a lot of layers. So this one is even too linear. Now, the bigger the model, the higher training time. The reason this tiny model has very high training time, I think there was some initialization. So just the first training run, I ran it multiple times, but just the first was huge. So maybe something was starting up in Google Colab, some GPUs or something. But other than the first one, everything, both are very short. So this should have the lowest training value. And then we have some other graphs. So this is performance, the higher the better. You see our medium model, our original is the best. So I guess this is just reverse loss. So you see here parameters versus performance. So medium has the best quality. So parameters, fewer parameters, but a good performance. And performance comparison here. So this is loss variance across trials. This is less important because we try to train it multiple times to see how much does the loss vary. You see here there are some lines and there are some lighter lines, so these are different losses from different training runs. Training time versus performance. You see medium is best again. It has many layers, it's deep and stuff. Now, what if we train on 2 images? Well, it will just learn to predict average of both of those images. So you see it's trying to minimize loss for both of the losses, both of them. So this way, the loss is minimal for both. So this is absolute minimal loss it can get. You can see here, if I scroll up here, this is the loss. Okay, we can see this loss. No. Let's look at this. So image 1 loss and image 2 loss. As you can see, the total loss is decreasing. So, and the total loss is 2 times. You see here is on the 2 times this scale, because we are adding both of these losses. So this is best it can do. You see here we are having total losses, loss 1 and loss 2. And loss 1 is this criterion. Here, MSE loss. But the target is image 1 and loss 2 is target image 2.